The direct spark ignition, or the DSI system, is only available on self-cleaning gas freestanding ranges. The supply voltage is critical for proper operation of the direct spark ignition system. The requirements are 102 to 132 volts alternating current with proper ground. If the electrical supply is less than 102 volts AC, sparking will not be reliable. If the system is over 132 volts AC, permanent damage to the DSI control can occur. A proper ground is also required. The DSI control generates a significant amount of electrical noise. This noise is minimized by clamping the noise to ground. If a proper ground is not connected, the oven control may periodically display PF, which means that a reset has occurred in the oven control. A proper ground is also needed to establish that a flame is present both at the cooktop and in the oven. The direct spark ignition system contains a gas distribution valve and a direct spark ignition board that interacts with the oven control and the spark electrodes. Let's look at the cooktop operation. All activity for the cooktop starts at the igniter switch. When the operator turns a burner switch to the light position, an igniter switch mounted on the gas valve closes and sends 120 volts of electricity to the direct spark ignition control. It also starts gas flow to the cooktop burner because we also open the gas valve when we turn the switch on. The DSI control in turn generates enough power to send an electrical spark to the igniters mounted on all cooktop burners. When one burner sparks, they all will spark. With gas flowing and an electrical spark present, the burner will light. The oven operation begins at the oven control. When a bake or broil cycle is started by pressing the keypad on the control, relays on the oven control board close and send an electrical signal to the direct spark ignition control. The DSI control in turn sends an electrical signal to the selected burner igniter and it begins to spark. The DSI control also sends a DC signal to the gas distribution valve to open the appropriate valve to let gas flow. With gas flowing and a spark present, the oven burner will light. Only one oven burner will operate at a time. This is the gas distribution valve. All gas flowing into the gas range must pass through this valve. Some of the features of the valve include a gas regulator for the option of changing natural gas operation to LP operation, gas inlet, and 3 gas outlets, one for the cooktop, the broil burner, and the bake burner. It also has electrical terminals for operation of the solenoids that must open to let gas flow to each of the oven burners. It has a shutoff valve that can stop gas flow to the oven. Gas flow to the cooktop is not affected by this shutoff. This is a close-up of the lever that closes the gas supply to the oven distribution cavity. When the lever is in the off position, the gas to the oven is sealed off, but gas will still flow to the cooktop burners. 2 solenoids are located in the gas distribution valve, one for the bake burner and one for the broil burner. Measurement across these solenoids is 216 ohms resistance. It takes anywhere from 8 to 18 volts DC to activate the solenoids. Only one solenoid can open at a time. The electrical connections or terminals are sized differently to help eliminate incorrect wiring. Note, when servicing the gas distribution valve, always check both solenoids. If one of the solenoids is defective, neither one will operate. All of the spark outputs are shown on the bottom of the board, but no measurement will be done here because the signals are very rapid and our meters can't give accurate measurements. All testing of the board is done at the J1 connector at the top of the board. We measure voltage in at 120 volts AC and voltage out at 8 to 18 volts DC. Here we can look at the wiring diagram. The cooktop operation starts when the operator turns the control knob to the light position. The igniter switch closes and provides 120 volts AC through the L1 side of the circuit to the board through terminal J1-9. Terminal J1-4 is the neutral side of the line and completes the circuit. This 120 volts goes through the board and generates sparking at the cooktop burners. The wiring diagram shows this operation. The other L1 line going to the board through terminal J110 supplies 120 volts to the DSI board to monitor the internal self-diagnostics of the DSI control board and the flame safety circuits to the oven burners. Oven burner operation is started at the oven control. As a bake function is programmed into the oven control, relays close on the oven control to provide 120 volts AC to the DSI control between pins J1-6 and J1-4. The board converts the 120 volts AC to 8 to 18 volts DC, measured at pins J1-2 and J1-1, to operate the bake valve and open the gas solenoid. Again, you will notice 120 volts AC is still available between pins J1-10 and J1-4. This again is required for the board to properly monitor the oven safety system. The DSI monitoring system is used for the oven operation only. It performs a self-test that checks to verify that the gas distribution valve is electrically wired correctly, and also provides a flame safety check that monitors the flame in the oven anytime a flame is required to be there. The monitoring system is not required for the cooktop burners. That is an operator-monitored system because the operator turns the sparking on and off as required. Here is a chart that shows how the DSI system works. The chart is a 4-second time span showing the operation of the oven DSI system. As the operator selects a bake operation by programming the oven control, the bake valve solenoid is open to provide gas to the burner. This is shown by the blue line. The spark capacitor on the DSI board charges, shown by the green line. And an electrical signal is sent to the bake igniter. The bake igniter sparks and provides the heat to produce an oven flame. If the oven burner lights, the flame sensing check operation, shown by the yellow line, will verify that a flame is present and the sequence is stopped. If the flame sensing check fails and a flame is not detected, the sparking will start again and perform another flame check to verify a flame is present. This will continue for the full 4 seconds as shown. At the end of 4 seconds, and a flame has not been established, the operating system will shut down for 40 seconds to dissipate the gas that was released into the oven because the valve was open for the full 4 seconds. At the end of 40 seconds, the oven will again attempt to establish an oven flame during the next 4 seconds. If a flame is not produced, another 40-second delay for gas to dissipate, and then a third 4-second attempt. If no flame is established at the end of 3 4-second attempts, the system will go into lockout. The oven control will continue to display the cycle you are in, the temperature you set, and an on indicator, but nothing is happening in the oven. The display will not move. The oven is in a lockout, and you must press the cancel keypad to reset the control. No indication of a lockout will be shown on the oven control. Lockout can be canceled by pressing the off-cancel keypad. What is a lockout, and why will the system ever go into a lockout? A lockout is a complete shutdown of the direct spark ignition system. The DSI board will not spark, and the solenoids on the gas distribution valve will close, so no gas will flow. All lockouts can be reset by pressing the off-cancel keypad on the oven control. The control will perform an oven system lockout if any of the self-test checks fail. The oven fails to ignite after 3 ignition attempts, as discussed previously. A flame is present in the oven for more than 10 seconds after the gas valve is turned off. Or the flame is unexpectedly lost for any reason after being established. Note: if the flame is lost, a lockout condition will occur within 30 seconds with no attempt to reignite. Again, to clear a lockout, press the off-cancel keypad on the oven control.